For decades, Bill Nye, famously known as the Science Guy, has captivated audiences around the world with his unique ability to make complex scientific topics both understandable and exciting. Through countless lectures, television programs, and public appearances, he has helped popularize science and inspire curiosity in people of all ages. One of his enduring passions has always been space exploration, and over the years he has kept the public informed about the ongoing efforts to unlock the mysteries of the universe. Now, Bill Nye is turning his attention to one of the most profound developments in modern astronomy, the discoveries being made by the James Webb Space Telescope, JWST, launched on Christmas Day in 2021 after more than 2 decades of development. The James Webb Space Telescope represents the pinnacle of human engineering and astronomical ambition. Built through a collaboration between NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA, JWST was designed to expand our cosmic horizons far beyond what even the Hubble Space Telescope could achieve. Unlike its predecessor, which primarily observes visible and ultraviolet light, the Webb telescope specializes in capturing infrared wavelengths. This allows it to peer through dense cosmic dust and observe phenomena previously hidden from view, offering scientists an unprecedented glimpse into the origins of the universe, the birth of stars, and the composition of distant exoplanets. According to Bill Nye, the early results from Webb are nothing short of revolutionary. The telescope began sending back its first images and data in mid-2022, and almost immediately, astronomers were astonished. Within months, the JWST had identified thousands of new galaxies, many of which are far older and more distant than anything previously seen. Some of these galaxies are believed to have formed just a few 100 million years after the Big Bang, pushing back the boundaries of our known cosmic timeline. These observations are giving researchers new insights into how the earliest galaxies formed, evolved, and clustered together into the large-scale structures we observe today. One of the most significant capabilities of the Webb telescope is its ability to study exoplanets, planets that orbit stars outside of our solar system. By collecting the faint light that passes through or reflects off of these distant worlds, JWST can analyze their atmospheres in extraordinary detail. Bill Nye notes that for the first time, scientists are now able to detect specific atmospheric components on planets located light years from Earth. This includes gases like carbon dioxide, methane, and even sulfur dioxide, which could serve as chemical indicators of potential habitability or biological activity. With each new observation, Webb is bringing us closer to answering one of the most profound questions of all time. Are we alone in the universe? One particularly fascinating region that JWST has studied is the famous Pillars of Creation. Located within the Eagle Nebula, originally made iconic by a 1995 Hubble image, these towering clouds of gas and dust are known to be active star-forming regions. While Hubble's visible light images revealed the majestic structure of the pillars, they couldn't penetrate the dense dust to show what was happening inside. That's where Webb's infrared vision comes in. Its new images reveal an incredible level of detail, including the presence of protostars, newborn stars still surrounded by the gas and dust that birthed them. These young stars appear as small red points in the image, and though they are not yet fusing hydrogen in their cores, they are well on their way. Nye explains that once a protostar accumulates enough material and pressure builds, nuclear fusion ignites, raising the internal temperature to millions of degrees and marking the birth of a true star. Webb's ability to see into the infrared spectrum doesn't just provide more data, it fundamentally changes how we interpret cosmic images. The colors in its images correspond to different infrared wavelengths, most of which are invisible to the human eye. Scientists use color mapping to represent these wavelengths visually, allowing us to see the dynamic processes taking place in space. For instance, redder hues typically represent longer wavelengths, which often correlate with cooler or more diffuse structures, while bluer tones may indicate hotter regions or denser concentrations of stars and dust. Another major milestone in Webb's journey came with the direct imaging of an exoplanet named HIP 65426b, first identified in 2017. This massive gas giant is nearly 12 times the size of Jupiter and orbits its host star at a distance 100 times greater than the distance between Earth and the Sun. This significant separation made it an ideal candidate for direct imaging, something that is rarely possible due to the overwhelming brightness of most stars. Using advanced equipment, including coronagraphs, devices that block out a star's light, and multiple specialized cameras, Webb managed to capture a detailed image of the planet, an achievement that pushes the limits of observational astronomy. Webb has also offered new views of galaxies that have long been studied with other instruments. One such galaxy is the Phantom Galaxy, also known as M74. Though it is difficult to observe with the naked eye due to its low surface brightness, its spiral structure has long intrigued astronomers. Webb's infrared capabilities revealed previously unseen features, wispy filaments of warm dust and glowing gas that weave through the galaxy's spiral arms like threads of silk. A stunning composite image, created by combining data from both. Webb and Hubble was developed by the ESA as part of the FANGS, Physics at High Angular Resolution in Nearby Galaxies project. This international initiative involves using space and ground-based telescopes to study 19 nearby galaxies in detail, helping astronomers map star formation and understand how galaxies evolve. One of Webb's most visually striking images came from its observation of a massive star known as Wolf-Rayet 140. Captured in July of the previous year, the image showed not only the star itself, but a series of concentric ring-like structures surrounding it. While part of the visual effect is a result of diffraction, a common imaging artifact, the concentric rings are real and have a fascinating origin. They are formed by periodic eruptions of gas and dust from the Wolf-Rayet star interacting with a smaller companion star in a binary system. These interactions create repeating shells of material, visible thanks to Webb's infrared sensitivity. Perhaps the most groundbreaking discovery Webb has made so far involves 4 of the oldest known galaxies in the universe. These galaxies date back an astonishing 13.4 billion years, just 350 million years after the Big Bang. Scientists were able to determine their age using Webb's near-infrared spectrograph, which measures redshift, a phenomenon caused by the stretching of light as the universe expands. The higher the redshift, the farther away and older the galaxy. With a redshift of 13.2, these galaxies represent some of the earliest building blocks of the cosmos. Prior to Webb, such discoveries were purely speculative. Now we can directly observe and analyze these ancient structures. In addition to studying distant galaxies, Webb has been instrumental in investigating individual exoplanets in remarkable detail. One standout example is the gas giant WASP 39b, which orbits a star in the constellation Virgo, approximately 700 light-years from Earth. This massive planet orbits its star much more closely than Mercury does to our Sun, causing extreme temperatures in its atmosphere. Using its powerful spectrographs, Webb identified several key atmospheric components, including carbon dioxide and sulfur dioxide. The presence of these gases, especially in such detail, marks a new era in planetary science, opening the door to studying weather patterns, atmospheric chemistry, and possibly biosignatures on planets beyond our solar system.